Okay, so what we're going to try to do with this little code example is I'm going to basically try to create fractions, we'll call ratios. And like in this line, I'm creating a ratio called A, and I'm saying its numerator is 1, the denominator is 4. Ratio B is 3 divided by 5. Ratio C doesn't have any initial value, so it will be set to whatever the default constructor says it's set to. If I don't overwrite the default constructor, it's going to be set to, in C++, it's going to be set to whatever storage was on the numerator from before, divided by whatever storage was on the denominator from before. So it would be a good idea to have a default constructor here. I'm sorry, yeah, a default, to overwrite the default constructor. And since we know from mathematics, denominators shouldn't be 0 because that leads to divide by 0 problems, we probably want to come up with a default value for a ratio, maybe 0 divided by 1, since 0 seems to be the default for integers and floats. We might as well have the default value be 0, but we want the numerator to be something non-zero. So maybe 1's a good choice for the default. We'd like to be able to take something, this type, ratio, is a non-primitive type. It's not something the compiler supplied to us like integers and floats and characters. It's something we made up, so it's considered a non-primitive type. However, we know that ratios can be multiplied against each other. People's last names cannot be multiplied against each other, but ratios can. We know how to multiply them, but the compiler doesn't. So we want to be able to teach the compiler how we would like it to multiply them together. And I created a method called print ratio. It just tells us what the values are. And then what I want to go over in this example is I want to have the constructors and the destructors print out, just basically saying I'm now running. So the code for the class looks like this. So here's the ratio class, same as Java or C#. Say class and then its name. We have a public section. What we're doing here is we're rewriting the default constructor. So what I'm doing is I'm outputting, basically I'm just going to print out lines, line 1, 2, 3, 4, 5 as this thing is running. And I'm basically saying I'm overwriting the default constructor. So that's all I'll do if that thing runs. I should have coded in a 0 or 1. I left that out. What's that?
It looks like you commented that right below that.
You guys commented?
Yeah, I commented. Well, this was one. What I wanted to put. The point I wanted to put in here. The point I wanted to put in here is one thing we can do. There's a thing you can do. This is just kind of like a side comment. We can have default values if a person doesn't assign values when they call it. So, for example, I could say, if you don't tell me what n is, I'm going to set it to 0. And if you don't tell me what d is, we'll set it to 1. But unlike Java, I don't know if you remember from your Java class, if you overwrite any constructor, the default that the compiler gives you goes away. Do you remember that in your Java class? If you write, so the compiler gives you one free constructor, the constructor that if you give it no information, it will do it for you. But if you overwrite any constructor, the default one will go away and then you'll have to write that one yourself. And that doesn't happen in C++. So this one could cause some ambiguity, whether it's the one that the compiler gave you or the one I'm creating here. So they don't allow this state where we can give default values for every single parameter. So I put that in the code, but I should have, for the default, let me just put it in right now. I should have added code that does this. I should have said numerator equals 0 and denominator equals 1. That'll be a default. Okay. Okay, so what else are we doing in this class? I'm saying you can supply a numerator and a denominator, and if so, with this line, I'm assigning the value n you give me gets copied to the numerator, and the value d you give me gets copied to the denominator field. So in the private section, I have a numerator, a denominator. I decided just for the printout purposes of this, I can name these things. I gave a one-character name you could give to the ratio. So I could say, you know, ratio S has a numerator of 2 and a denominator of 5 if I wanted to. And then I created a static variable. Remember what a static variable was? That's the same in Java or C#. This class has a variable, but it's not each object has its own value. It has one shared one for the whole class. So when I go to print this out, I can keep incrementing the line number, but it's the same increment for all the objects. So I can make 5 different. Objects that have a ratio in it, but they'll all share the same line number. So it'll just all be printing out 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now I have a. This is also true for any programming language. I have a constructor that takes as input some other ratio. So when would you need something like that in a programming language? Do you remember an example where you might need something like that? So suppose you said like ratio A, you're declaring a new ratio, ratio B equals ratio A. Like not only am I creating it, but I want its values to come from an already existing ratio. So we're creating it, but this is what they call the copy constructor. That's when you're creating a piece of data, but you're copying its contents from an already existing piece of data. And then in C++, we have this concept of a destructor. This is something that runs, a program that runs every time an object goes away. If all you care about is that the data gets erased, you don't have to put any code in here. But this code will run prior to the data all being erased. Okay. Now we've decided we want to teach the compiler how to multiply two ratios together. So the code, let me go to the code that multiplies them together first. Here's where we're telling the compiler how to multiply two ratios together. So the operator star, which means multiply, and that works, the compiler already knows how to do stars of, like, you know, integers and floats, anything that's scalar, anything that has value to it. We can multiply. We're now trying to teach the compiler how to multiply these two ratios together. So it's going to take as input two ratios, I'm calling them x and y, and then I'm creating a temporary, like a result one. I'm creating result one, and then I'm saying the results numerator equals x's numerator times y's numerator, and the results denominator equals x's denominator times y's denominator. Once I've calculated x plus y, I return it. And I'm saying I'm returning a ratio. So this line would then, this line down here, which says C equals A times B, is now understandable to the compiler. It will take A's numerator and B's numerator, multiply them together and actually store them into a temporary field, and then the denominators also go into the temporary field, and then the temporary field will be returned to C. So now the only other issue was, if you remember, we decided to make the numerators and denominators private. So the numerator and denominators were private, but the operator function accesses them. And since the operator function is not part of the class, it doesn't have access to it. Private means anything outside of the class cannot access it. So what we decided to do was to allow the ratio class to give permission for the operator star function to have access to the private data. So the way we do that is we say within the class. If you think about it, we couldn't put it here because then anybody can become friend of anything and start going into the private data area. So only the owner of the ratio class could say, I want to allow the operator function to have access to the private section of this class. So we could do that in C++ by declaring that the operator star function is a friend of the class. So we say friend, and then we write out the whole signature of the function. So we're allowing ratio operator star, ratio x, ratio y to be a friend of the ratio class. That now makes these lines compile. Actually, yeah, it's these two. We're accessing the private data. So this would allow those two to compile, and then therefore this line, C equals 8 times B, would compile. So the compiler now knows how to multiply two ratios together, and we've given access to the ratio function so that it will have access to the private data, the numerator and denominator. And we can print it out. And let's go back to the class to see what other functions there are. Okay, so that was the friend one. Now I decided to add a method called print ratio. And if you remember, there's a method I think in Java called toString that will basically take any class object and convert it to a string, and you can spit it out. But this gives us an opportunity to print it any way we like. So I decided to print out, I'll say like the ratio is, the numerator, and then a slash line, and then the denominator. Tell us what the value is. And then we could add other public functions like double a ratio. So if you wanted to double a ratio, what would you do? You multiply its numerator by 2. If you want to cut it in half, cut its numerator in half. If you wanted to give it a name, and I just decided to give these one-character names, you give me a name and I'll assign that name to it. So the ratio could, if we decided to have a name. And then I've taken this static variable line and set it initially to 1, and then just let the program run. So if I compile this and run it, well maybe what we can do is try to guess what the output would be. Let's say G++ is the GNU compiler for C++, and then it was called ratio. Okay, so wait, what do we think the output of this would be? Let's first look at the first couple of lines. I'm creating a ratio called A. I'm saying its numerator is 1, its denominator is 4. Then I'm creating a ratio called B, numerator 3, denominator is 5. Then I'm creating a ratio C. Let's just go up to these 3 lines. What output would get generated? So we're not doing anything, right? But I've decided in my constructors to start spitting out informational messages. So if I create 2 ratios with, if I create 2 ratios by providing a numerator and denominator, and create a third one without providing any information, what happens? What constructors would run? Yeah?
You get the parameterized constructor to run twice, leave the default. So A would be parameterized.
This one.
Yeah, and B would be the
So
same.
it should print out, it should say line 1, close paren, parameterized constructor called. Well, maybe I should have printed out the values too. Okay, and then that'll come out twice. Then the third one, where I just create a constructor, I'm sorry, I create a ratio with no information, what would come out?
The default constructor.
Which is, yeah, it should say overwritten default constructor call. That's this one should run. And its value should be 0 divided by 1. Okay. So that should be the first 3 lines of our output. Those ones are kind of easy. Now, I say C equals 8 times B. What output would come out? Let's see. the line C equals A times B. Now remember, normally that shouldn't generate any output, I'm just doing computation, but everything that gets constructed or destroyed, for demonstration purposes, I'm printing out a sentence. So does that line, C equals A times B, construct or destroy anything?
Just alters the value of C.
Well, it's gonna do a lot of work, and when it's finally done, C will equal 3 divided by 20. When all the work is done. But does anything get created? So what I'm doing up here with
Yeah, wouldn't there be a copy?
right, every time something gets created or destroyed, I'm spitting out a message saying something got created, something got destroyed. Normally you wouldn't do this. I'm doing this just for for demonstration purposes. But is anything, when we do the line C equals A plus B, do any ratios get created temporary or real, or does anything get destroyed along the way? So when you say C equals A plus B, what happens? This function runs. And now we've set it up because we made this a friend of that one, and we've taught the compiler how to do this. This is going to run. What's going to happen? The contents of A, the ratio A, and the contents of ratio B go where?
Go into the contents of C. So
Wait, so it's this line right here. C equals A times B. The values of A, which is numerator 1, denominator 4, the 1 and the 4 get, for this line to run, what has to happen? The contents of A gets copied where? Somewhere. The contents of B gets copied somewhere. Then, and what else is happening?
R is getting created. Yeah, R is getting created.
R is getting created, but is anything else, even before R is created, is anything created? So basically, so now you're saying this will cause a default constructor has run. This will cause a variable to be created, and
Then it's value.
this close paren will do what?
return the statement, return R.
This will return R, but the close paren will destroy anything created since the most recent
yeah.
open paren. So this R that got created will get destroyed by this close paren, right? Because we don't want that storage hanging around. The whole mechanism to the open paren close paren is to destroy everything that is no longer needed. Yeah?
So are you saying then, when you hit that close parenthesis, then that's when the destructor will come in? Or do you have to explicitly call the destructor?
That ends up being a good question. So this is a good side conversation. Have you ever, did it come up in Java that the topic of did something along these lines come up? When you create primitive types, they get created on the stack, and when you create non-primitive types by doing new, they get created on a heap. Did that ever come up?
I mean, we talked about heaps and stacks, but we didn't go into like that.
Yeah, that's no.
How did heap and stack come up?
Data structures.
No,
It also came up in 120, I think.
Oh, really?
Yeah.
I remember that.
okay, well anyway,
I just remember.
there's basically two types of storage called heap storage and stack storage, and it kind of comes from heaps and stacks in your data structures class. But the idea is basically this. As far as getting rid of storage, any piece of storage that is gotten from, by declaring the storage, by saying like ratio R, that means it's gotten what they call on the stack. And everything, so you're thinking of a stack, you're piling something on top of each other. So if we have an open paren and we get some more storage, that storage is available in addition to all storage from lower level open parens. Right, so as the open parens keep going inward, the new stuff on the inside plus the previous stuff is all available to us. As soon as we hit the closed paren, anything created since the most recent open paren gets popped off the stack and is all of a sudden gone. But what was there before is still around. So that's why they call it a stack. Each of the open paren, closed paren pairs puts a new chunk of storage on top of the stack. But there are some times that we want to create a piece of storage here so that when we hit the closed paren, that piece of storage is still around. Sometimes we want to create a piece of storage for someone else to use later. And we don't want our closed paren to kill it. So in C++, if you decide you want to create something on the, if you want to create a piece of storage that will not go away when you hit the corresponding closed paren, you explicitly say ratio equals new ratio, and that will tell the compiler, I want this to stay around after the closed paren. And that's considered creating it on the stack. So what's the advantage to creating something on the, that would be creating it on a storage system that doesn't go away when the closed paren hits, so not on the stack, what they call a heap. And a heap from your data structures class was like a pile of disorganized records, and a stack is very organized. You can know what's on the top and when to get rid of stuff. So when you create storage on the heap, you're explicitly doing that so that someone could use it later on. What the creators of Java decided to do was to make every piece of storage that ever got created that is not a primitive type is automatically created on the heap. The advantage to that is you don't have to worry about things accidentally getting deleted that you might need. The disadvantage is it's harder to access something in a heap than it is in a stack, so the access time could take longer. But they felt it was safer to do that. But in C++, so it's a good question. We have a choice. We can create anything on the stack, meaning the corresponding closed paren will automatically get rid of it, and we can create it on the heap. You have to just say equals new and then create it, and that means it'll stay around after the closed paren gets hit. Okay, so just that call that says ratio A times ratio B equals ratio C will cause this function to run. What gets created and destroyed just in the running of this function? So we said we're going to create this one called R. That's going to get created. This closed paren is going to cause it to be destroyed. Does any other temporary ratios get created? Now, because you're used to the idea from Java that X and Y look like references, like another name for some existing piece of storage, right? It looks like X is going to be another name for A, and Y is going to be another name for B. But actually, if you remember last class, we said if you put an ampersand in front of it, that's saying this is a reference for an existing piece of storage. If we don't put an ampersand in front of it, then it's its own piece of storage. So a brand new ratio is going to be created for X, a brand new ratio is going to be created for Y. A is going to get copied into X, B is going to get copied into Y, then a brand new ratio for R is going to be created. So 3 ratios are going to be created just to run this function. One for X, one for Y, one for R. The one for X is going to be created using the copy constructor, because we're copying the contents of A into X. It's exactly like saying ratio X equals A. Like this line right here is basically like saying ratio X equals A, ratio Y equals B. Then R will be created, this computation will be done, which won't create or destroy any storage. Then we're going to return R. This return of R will take the contents of R and copy it to C. So that actually, that's not a constructor, that's a copy operator. I didn't overload the equals operator. I could have described what an equals was, but I didn't do that. Okay. So as far as copying and destroying is concerned, we're going to create an X, a Y, an R, perform a computation, return the value of R to C. That won't print out any output. Then this closed paren will cause the X, the Y, and the R to all get destroyed. So just to get through this line here, there's going to be 1, 2, 3 constructors, 4, 5, 6 constructors, a computation, then this return value, we won't see anything, and then this close paren will destroy 3 ratios. And then we'll be ready to hit the next line. So let me just compile this. We'll look at the first couple of lines. Or let me just run this down. So what's happening here is this starting off right? 2 parameterized and 1, yeah, that's what we expect, right? Yeah, the 2 parameterized ones would run. Then the overwritten default one. This is the default one which says the numerator is 0 and the denominator is 1. Now this line hits, and here's where it starts getting crazy. Let's see if we can trace everything that happens. I'm thinking A should be written to X first. So, yeah, the 2 copy constructors, the line number 4, these 4 and 5 are copy constructors. That's the contents of A being copied into the new ratio, the new temporary ratio, X. And the contents of B copied into Y is lines 4 and 5. Then, this one gets created. Line 6 is a default one. That's another one with a 0 and a 1. These 2 lines don't create or destroy anything. This return copied the contents from R back to C. Now, another operator I could have overloaded in the class was the equals operator. So if you say, you know how you could say A equals B, if A and B are integers, you copy the values over. In C++, the idea of having an equals operator that you could overload might make sense. If you wanted to copy every value field for field, you would just let them copy it over, right? Copy the numerator and denominator. But suppose you had, like we talked about last class, suppose we had a pointer, and the pointer points to some chunk of storage. Would you want the new one, if you're copying from A over to B, would you want B to point to the same piece of storage, or would you like to create a brand new piece of storage and have it point to that one? That's your choice. So in C++, there's the idea of creating an equals operator. If you say A equals B, not that you're creating a new piece of storage, but 2 already existing pieces of storage, and say A equals B, you can describe how to do an equals. So like it's up to you to do it. But I didn't bother writing that. So that's why this line, this return, won't print out any output, but I could have overridden the equals operator and just said, I'm now returning. And then we hit this close paren. Now I'm saying at this close paren, the X, the Y, and the X, the Y, and the R gets deleted. And they should get deleted in reverse order. So objects, this is, as we said, this is on the stack. So the variables X, then Y, then R were stacked up, and we delete by popping off the top of the stack. So it should get deleted in the order of R first, then Y, then X. So the destructor for, I should have named these. This is the junk that was in the field before we got here, the character that I gave the name. But this is basically R, which is the result, which was, what do these things equal? Yeah, 1 times 3. Yeah, 3 divided by 20. So this is, I'm destroying R, then I'm destroying
X. Yeah, X, which is copy that.
Huh. Wait, I should be destroying.
9 and 10, you have a new line character, so that's why it's split.
I should be destroying R, which is 3/20. Then I should be destroying Y,
Yeah.
which is
3/5.
B, 3/5. and then I should be destroying X.
It's 140.
Yeah.
When,
This looks like X.
Yeah.
but doesn't it
And what
work
is
left to right associative, so it only had to make a copy of the one? And the compiler knows to work off of the actual value of the second parameter? I can't remember how the compiler thinks when it goes down the tree. But it only needed one value to set aside.
Wait, you're thinking, this doesn't seem right.
And what is it constructing in line 9?
No, line 9 and line 10 are one line together. You can get a new line character out of the, in that destructor.
9 and line and 10 are the
Wait,
same
no.
one.
No, 10's the print.
10 is the
Scroll up
the
to your,
print ratio.
your destructor
Yeah,
up there. You had a new line character up there.
Oh yeah, he doesn't have a new line. Oh no, he does. He has an yeah.
Yeah, but in line here.
Yeah.
Those were working normally an hour ago. All I'm doing when I destroy something, this is my destructor, and all I'm doing when I destroy something, I'm just printing out, I am destroying. The name of it equals, numerator of it, divided by the denominator of the new line. All right, well, we'll try to explain that more. Then what else is coming?
10 is the print out.
Print.
Yeah.
Print. The print.
Current ratio of
Print
C,
ratio.
did that come out normal?
Yeah.
Yeah, okay.
Yeah, that's 10.
And it's called M, so that must be just some storage that was there before. All right, so then the next line. So now I'm just demonstrating now calling a function. So we kind of demonstrated when just multiplying, creating temporary storage to perform a multiplication does a lot of creating and destroying of new objects. So now saying I have a new ratio Z, so this should cause a overloaded default constructor to run. I'm naming it Z. I'm taking the already existing, I'm creating a brand new
Yeah,
X.
another-
This is
yeah.
not, this is a different X from the one before. I'm making that one 1/4, I'm naming it X. I'm creating a Y, and I'm copying its contents from X. So this should run the copy constructor. That's a different constructor, that's the one. So the one that's being run here is called a copy constructor. And this is similar in Java and C#. That's the constructor where, here's a constructor, right, same name as the class, and it takes as input a reference to another ratio. So this one only runs when you call it by giving it another one. So I'm saying the one that you gave me is numerator becomes my numerator, the one you gave me is denominator becomes my denominator. And then I say overwritten copy constructor. So let's see if that matched exactly. So that would be
Line 13.
wait, let me go back to the code. So Z getting created is a default constructor. Overwritten default constructor, that's 11. Then Z gets named, that won't create anything. Ratio X is a brand new parameterized constructor, that's that one. Naming X doesn't do anything. Y getting copy from X would run a copy constructor. Then I doubled Y and I named Y, that shouldn't do anything. Okay, and now I'm saying, now I'm calling a function. Z is equal to f of Y. So I'm calling this function. And what does this function do? It creates a temporary ratio called R and copies the contents of Y into R. So we should, the next line should be a default constructor. Overwritten. Oh, sorry, it should be a copy constructor. Where were we? Here? This one, okay. And now I'm naming it. I'm now saying a ratio S is equal to R. This would be a copy constructor. That would be this one. And then I'm naming it, I'm doubling it, and then I'm returning it. When I return it, the value of S gets copied back to Z. So we won't see any output from that. This close paren will then cause R to get destroyed, and S to get destroyed, right? So it would be S first, then R. So, let's see. The destructor of S, yeah, the destructor of S and then R. So, I don't know what's wrong with that first one. This looks normal, right? We're destroying them in reverse order. So the first one that got created was the parameter R. The second one came later on, which was S. The close paren then caused the S to get popped off the stack, destroyed off the stack first, then R. So that's why S got destroyed and then R got destroyed. And then the rest of the way, I'm basically just printing out the results. I don't know if there's anything surprising here. X equals 1/4, that's what we set it to. Y should equal what?
It's double.
Y was, we doubled, what was the point of this function anyway?
Y was
We
X.
printed it, we named it, we printed it, we copied a value in, printed some stuff, copied it over to something, printed some stuff, then doubled it. So S was what came in and got doubled.
Yeah, but R was never changed, and Y was never changed after it became R either.
No.
Right. So R is 2/4. Oh, you're saying this shouldn't be 2/4?
No, it should be 2/4 because nothing was done to it.
Wait,
But why? It's
R was,
R and Y are the same because Y is cast as R.
oh wait, hold on, okay. X was 1/4, Y,
becomes double.
X got copied into Y doubled.
Yeah.
Yeah.
So
Then
becomes
Y, which is 2/4, got passed into here
To R.
to R got copied over to S got doubled, that should be 4/4.
Yeah.
Yeah.
That should be 4/4,
Yeah.
okay.
Which is
So R is
Which
2/4, S is,
Yeah,
okay.
yeah.
Alright, good. But I just can't explain that first one, it's the same thing, the popping off backwards. Somehow, we can take a look at that one later. Okay, and then, I thought the rest of this was interesting, but maybe not. What am I doing? I'm doubling Z, the result, and then I'm printing X, Y, and Z. Printing X, Y, and Z, which were never named. But Y was named.
X is named too.
Z is double of Y.
Right, and Y was named before.
Yeah, your F, Y was, 2/4?
Y was,
No.
no, Y, I never named Y, so Z was never named. Right?
No, Y is
No,
named.
Z was
Yeah, no.
renamed to S.
Was?
Yeah, because when you throw F of Y, to assign Z, it goes up to the top function F, which renames it.
Yeah,
Because
when I
that
said
becomes
Y
R.
was, so Y, wait, was Y named, Y was named Y.
Yes.
Copied that into this function,
And then there's
so
double
it
in that
should have,
function.
Z should be named Y.
It's changing, funny, it's not.
S got
got returned, yeah, why?
Wait,
So-
why is Z named Y?
Was it? Okay, so, I kind of remember the point of this, okay. Why
is a double version of X?
why is it, why was created based on X,
So it was created as one for.
which was named X? So why was, at this point, Y was named X?
But then Y is doubled and
Then Y got renamed to Y
Yes, after being doubled.
after being doubled. Then Y was passed in to create Z. So Y's name should be Y. Z,
But Z was named
Z-
before X was even created.
Yes.
yeah, but didn't its name change? Right, Z was named Z, but then when Z became F of Y, it should have
Z
taken
became
on.
S? Yes, yes.
It
Z
should have
became-
taken on everything that came back, right? So it
Which
should
is the
have,
last one.
when Y got passed into here, its name became R, and then this new thing became S, and S got returned.
But
It should have been called S.
Yeah, Z became to S and
Z
it's
should,
doubled.
Z's name should be S and it should be doubled.
Yes.
So why is Z? So
It does have it.
No, I thought it was garbage.
Yeah.
No, it's right there, S as 4, 8, fourths.
Right, and then you've got the destructors.
Oh, okay, yeah, up to. Oh, I'm
0,
sorry, I'm
19,
sorry,
20,
I'm sorry, I'm looking at these values thinking these names should have been there. So, what got destroyed last?
S.
The 6 things that got destroyed at the end was what? R, S. So let's see, the destructions happen in stack order, so A got created, then B, then C, then Z, X, and Y. So they should get destroyed in the order of Y, X, Z, C, B, A. Does that sound right? Y, X, Y, X, Z, but S got sent
S,
back,
yeah.
so that looks right. This should be C, B, and A, and it's all garbage that was there before. Did we never
C-
name
I don't
those?
think you ever named
Well,
them.
We
yes,
never named them.
C,
Okay.
yeah, C is, well,
Okay.
yeah.
The values are right, but the names were never classified.
Yeah.
Okay, so that's why it's garbage,
Yeah.
whatever characters happen to be there before. Okay. So the only thing I can't explain is this section. This should have been 3/20ths, 3/5, and 1/4. If everything got destroyed in the reverse order that we had caught. So, all right, we can let that be our homework assignment for next class. Try to figure out why that didn't happen. Okay, so, but yeah, the point